Hi, in this video I'm going to be looking at radians and what they are and how they're defined and how they link to the angle measurement degrees. Now, we don't use degrees in a lot of mathematics and sciences and engineering because it's rather arbitrarily defined. The theory is that the Babylonians came up with degrees many years ago because they had a base number system, or it was a base 60 number system, or it was because they thought that there were 360 days in a year. Whatever the theory is basically just what they came up with. Whereas radians are a lot more useful to applications, especially used in maths and sciences and engineering, because they are defined geometrically. They actually have a mathematical geometric definition. And so that's what also makes them the SI unit for measuring angles. And where they come from is if we start off with a circle. So if I start off with a circle and I draw on the radius of that circle, whatever the radius of this circle is. And if I get this length, whatever this radius length is that we've got here for our radius, and I want to try and draw it, but I'm not going to draw it as a radius. I'm going to take the same distance and I'm going to draw it around the circumference of the circle. So whatever this radius distance is, we draw it around the circumference of the circle, and that measurement, well, this action will get us to rotate effectively around the circle. And so then if I complete effectively the sector that I've got, where this is another radius, so these distances, that's a radius, they're both straight, and this is a curve around the arc length. It's an arc length of the radius, and we end up creating an angle or a sector with that angle in it. And the size of that angle is 1 radian. So this angle that we've got is 1 radian, or 1 radius around the circle, which is why they're called radians. So this angle that we've got, this one here, is physically, well, not physically, but is mathematically defined based on whatever the radius is, move around the circle. And this is a great system because it doesn't matter how big your circle is, 1 radius is still 1 radius. Now, that's what 1 radian is. But how does that help us? I haven't even really given you a value. It's just I've just called it 1 radian. And I haven't even told you how big that is. In terms of degrees, I believe 1 radian's around about 57 and a bit degrees. It doesn't even perfectly divide in. So 1 radian on its own is not tangibly useful. But where it is useful is because this has a geometric definition. If I think about the full circumference of this circle, the definition, well, the rule for the circumference of a circle is 2 times by pi times the radius. Or if we think about it, the circumference of the circle is 2 pi lots of radiuses. So that means that if I keep doing this, I've got 1 radius, and I'm going to get a second radius, and then we'll get a third radius around there. So that's 3, and we can get a 4th radius around here, and we can get a 5th radius in, and if we go for a 6th radius, I'll end up a little short. Now, I haven't drawn my radiuses perfectly, and I think my first one, my blue one actually, I think is probably a bit the biggest, but 2 pi means that there's going to be 6 and a bit radiuses, or 6.28 if you want to think about pi as being 3.14. So we can get 6 and a bit radiuses in there, but the important thing is that a full circle is actually equal to 2 pi radians, or a full rotation, we should really say. So a full circle is 2 pi radians. Now in degrees, we know a full rotation around a circle is 360 degrees. So we know that 360 degrees is equivalent to 2 pi radians. Now, radians don't actually have a unit because of the way that they are defined. They are physically just the distance you travel, one radius around the circle. So we never put a degree symbol, or you might occasionally see a little C or a little R just to denote that the number is a radian. And that's especially if I do want to write 1 radian, it's probably going to be easier to write 1C, because 1 on its own could get a little confusing. So now we have this. 360 degrees is equivalent to 2 pi radians. And a lot of people don't really use 360 degrees equals 2 pi as their definition or a useful calculation within radians. What we usually do is if I divide both sides of this equivalent statement, I can get 180 degrees is equivalent to 1 pi. So a single rotation around a single half rotation, so halfway around my circle, is a rotation of 3.14, which is why I fit 3 and a bit in there. Well, that's where I've gone wrong drawing my circle to begin with. And so we've got 180 degrees is approximately equal to 1 pi. And we can keep dividing. If I divide by 2 again, I can get that 90 degrees is equivalent to half a pi, or pi on 2. And if I divide by 2 again, we'll get that 45 degrees is equivalent to a quarter pi, or pi on 4. And so now these are the numbers that people start typically using. 360 degrees is 2 pi, 180 is pi, 90 is pi on 2, 45 is pi on 4. There's a couple more we can get. If I go back to that 90 degrees, and instead of dividing it by 2, I divide it by 3. So that'll give me 30 degrees. And a third of a half is a sixth. So I've got pi on 6. And if I double that, then we'll get that 60 degrees is equivalent to pi on 3. So now this is how people start using radians to map to degrees, or to help them figure out how big a particular angle is. If I am asked to draw an angle of pi on 4 radians, then I know to draw it to try and get an angle of 45 degrees, because they are equivalent. They're the same angle, different measuring unit. And of course we can get any multiple of these as well, because I can also go and, well, if I do 180 plus pi, well, that's going to be 270 degrees, and that's going to be equivalent to pi plus pi on 2. 180 plus 90 is 270. Pi plus pi on 2, well, that's going to be 3 halves of pi, or 3 pi on 2. So if you've rotated down here, that's a rotation around to 3 pi on 2. And so now we are seeing more angles come out. And I can get any multiple of this. If I want, say, 120 degrees, well, 120 degrees is 4 lots of 60 degrees. So that would be 4 pi on 3. So 120 degrees would be equivalent to, well, it'd be twice 60 degrees. So it'd be 2 pi on 3. If we went for 240 degrees, that would be 4 pi on 3. So you can just keep getting more and more angles by taking our base ones, especially these 4 that we tend to work with. So most people work with the 3, 45, 30, and 60, or even just 30 and 45. Any multiple of those, we can work out what the degrees or the radians equivalent is just by using these mappings. So that's what radians are. And that's how we connect them to degrees. And they actually have a lot of uses, which we'll look at in other videos, around being able to shortcut calculating things like sector lengths, or arc lengths I should say, or areas and things like that.